Okay, in this video, we're going to be looking at tangent theorems, and tangent theorems are very easy theorems. And under tangent theorems, we're going to be looking at two different theorems, and you're going to see how it works. Now, first of all, can you pause the video and define the word tangent? What does it mean when you say tangent? All right, so if I have a circle with a center, a line that is being drawn and touches the circle at only one single point is what we call a tangent. So looking at this, it's touching at just this point, and that becomes a tangent. On that same circle, I can as well have this as a tangent. See, meeting here can as well be labeled as a tangent. So this is what we call a tangent. Now, what theorem are we trying to consider here? Now, the theorem we want to consider here states that radius is perpendicular to the tangent. That radius is perpendicular to the tangent. So the keywords there are perpendicular, especially this is the major keyword. Also, radius is very important here, and we also have the word tangent. So let us try to see what this theorem says diagrammatically. Now, when you bring this diagrammatically, what this theorem says is, if I have a circle and I have a center and I have a line, a tangent, which is this, so label this tangent as ATB, and this is a center O. A line drawn from the center up to your point C, which is a point where the line touches the circle, is always 90 degrees. That is what it is. So the radius is perpendicular to your tangent. Don't forget that perpendicular means 90 degrees. So when your radius touches the tangent, that is a point of the tangent, then what it forms is what we call 90 degrees. So automatically, if I do some joining, then I would have what we call a right angle triangle, which I can definitely use Pythagoras theorem to solve, or I can use the trigonometric ratios to solve. And the trigonometric ratios are so catois. Yeah. So let's examine a couple of questions. One second, please. Okay, so I have this questions. Now you will see how direct it is. Now I have this 4 questions. So if you examine this, this is the radius touching the tangent here, so this becomes 90 degrees automatically. So definitely x plus 27 plus 90 equals 180 degrees, which means x plus 117 is equal to 180 degrees, and x equals to 63 degrees. Here as well, this is the radius, so the tangent, so this is 90 as well. In this case, this is an exterior angle, so the first thing you do is to get this interior angle. So label it as A, and that tells you that A plus 154 equals 180 degrees. Sum of angles on a straight line, and A is equal to 180 minus 154, which means A is 26. Now, I know this is my radius, and I know this to be 90 degrees. So that means I would have 90 here. I already know here to be 26. Now, don't also forget that this is x. Automatically, if this is x, the inside angle here will be 180 minus x. So that gives you what? 26 plus 90 plus 180 minus x is equal to 180. And this will give you 26 plus 90 is 116, plus 180 will give us 296 minus x is equals to 180. So that means that the value of x will be 296 minus 180 equals x, and that makes my x to be 116. And for this last one, this is my 90 degrees, then I will do x plus 2x plus 90 equals 180. So 3x is equal to 180 minus 90. 3 equals 90 and x equals 30. So this is how you run the radius perpendicular to the tangent. Can we also quickly look at one or two application questions that has to do with Pythagoras theorem and trigonometric ratio very quickly as well. So I'm going to have just one question each. So I have this, I pick this, then let me pick the second one, then we'll try to solve it. So we will as well pick this. Good. So let's see what we can do from here. So looking at the first one, let us identify the radius. This is the radius, this is the tangent. So this is 90 degrees. So obviously this is my hypotenuse, and that means I'm going to use Pythagoras theorem, which says that hypotenuse squared equals opposite squared plus adjacent squared. So that means I'll have x squared equals 5 squared plus 12 squared, which means x squared equals 25 plus 144. X squared equals 169. X is the square root of 169 and x is 13 centimeters. And here, this is my radius, this is my tangent, meeting here, which is 90 degrees. So this becomes the hypotenuse. Since this is the angle we are looking for, the side facing it becomes the opposite, and the third side becomes the adjacent. So the consideration is between opposite and hypotenuse. So going back to your SOHCAHTOA, what trigonometric ratio combines opposite and hypotenuse? That is SO, which is sine. So sine x is equal to opposite over hypotenuse, which is equal to 15 over 12. Okay, there's a problem with this question. This is meant to be the 15 and this is meant to be the 12. So that will give you 12 over 15. So x becomes arc sine of 12 over 15. And what will be the result of arc sine of 12 over 15, which must be corrected to 3 significant figures. So let's check that very quickly. Arc sine of 12 over 15, and that gives us 53.1 degrees. And that is how it works. I hope it is clear, and I hope you have a better understanding of this. Okay, quickly, we're going to quickly consider another theorem. And that second theorem talks about tangents from an external point tangents from an external point are equal. That's what this says, that the tangent from an external point are equal. And I want you to please pay utmost attention to this as well. So what this theorem says is, if I have a circle which is a center, now this is a tangent, this is another tangent. Now what the theorem says is that I know that a line that I draw from this center to this part gives me 90. A line that I draw from here to here gives me another 90. Now there is something we call the line of symmetry. Now a line drawn from this center up to the point where the two tangents meets is called a line of symmetry. And what is a line of symmetry? A line of symmetry is a line that divides a shape into two equal parts. So what happens is that whatever, now if I label here as A, I label here as B, and I label here as T, whatever happens to triangle OAT happens to triangle OBT. And you can see clearly this is already 90, this is 90. Now, because this is a line of symmetry, this angle here will also be equal to this angle here. And automatically, without missing words, this angle here will also be equal to this angle. So the meaning is this: angle OAT is equal to angle OBT. That is 90 degrees. Also, angle ATO is equal to angle BTO. That's the angle where the line divides itself. And automatically, this angle at O is also the same. So the implication is that line AT is equal to line BT. So if you are able to get this line of symmetry, the conclusion is that this tangent AT will always be the same as tangent BT. And that is what that theorem is talking about. So we're going to look at one or two questions on that as well. And I hope it would be very, very clear. Okay. Okay. So we look at this question. Okay, so for this question, I already know this is my radius and this is my tangent, so this forms 90 degrees. This is another 90 degrees. So that means that x plus 90 plus 158 plus another 90 equals to 360. Why am I doing 360? Because this ABOC forms a quadrilateral, and the sum of angles in a quadrilateral is 360 degrees. So this gives us x plus 180 plus 158, that's 338, which is equals to 360. So x becomes 360 minus 338, and x is equals to 22 degrees. Good. One more question. So we can, let's do this. You can as well use this to, you can as well use SOHCAHTOA in this kind of theorem as well, because it's still all encompassing. So let's look at this. This one now, we know here to be 90. We know here to be 90. We don't know here, so let's say it's m. So that gives us m plus 90 plus 23 plus 90 equals to 180 degrees. Now let me quickly say something. If I draw a line of symmetry here, what it means is that this will be 11.5, this will be 11.5. Please take notes. So m plus 180 plus 23 is 203. Oh, sorry, equals to 360 because it is a quadrilateral. Sorry, not 180, please. So equals to 360. So M will now give us 360 minus 203, which will definitely become 157 degrees. So the implication is that if this is 157, it will be divided into 2. So what will be our X? X will now be 360 minus 157, which is sum of angles at a point, and that is 203. So these are what we call the tangent theorems. So let's not forget, the first tangent theorem says that the radius is always perpendicular to the tangent, and the second tangent theorem says that the tangent from an external point are equal. I hope you've been able to learn something from this video. Thank you for watching.